quotient law with a complex base. The law that gives that x over y to the power of n is equal to x to the power of n over y to the power of n. We can see in this example here that x over y cubed means that the base is multiplied by itself 3 times. So x over y, and x over y all multiplied together. Just a reminder of how we multiply fractions. Okay, so we multiply across. So 2 times 4 would give me 8, and 3 times 5 would give me 15. So when we're looking at this, we would multiply x times x times x across the top, and y times y times y across the bottom. So x times x times x gives x cubed on the top, and y times y times y gives y cubed on the bottom. So when we're looking at questions like this, we're saying how many x's are being multiplied on the top and how many y's are being multiplied on the bottom. Let's try an example. Okay, so let's say we have a squared on the top and b on the bottom, and we are cubing this. That means we'll have a squared times a squared times a squared over b times b times b. How many a's do I have on the top? 2, 4, 6. A to the power of 6. How many b's on the bottom? 3. We can see how those connect here. Power of a power rule, 3 times 2 is 6. Recall that when you don't see an exponent, it's an exponent of 1. So 3 times 1 is 3. And you can see 6 and 3 here. Let's add in a little more complicated question. I think you can handle it. What if we're not working with power of a power? What if we had a squared b over a b? What would we do then? Well, let's write it out to see what that means. So this is a times b, and on the bottom we have a times b. Now, if we have a number over itself, like if we had something, if we had something like this, 2 over 2, 2 out of 2 is 1 whole. So anytime we have the same number on the top as on the bottom, like this, division, we can cancel these out. And this cancels out, okay? So that leaves us with just one a, just an a on the top. Now recall that when we used our other exponent rules, that we did subtraction when they were being divided. So here, this is a division statement, a squared b divided by ab. We can only apply the exponent rules to bases that are the same. So b and b, top and bottom, are the same, okay? And these have, this base has an exponent of 1, and so does this. So when we go to use our exponent law of subtraction, it would be 1 minus 1. So let's talk about that. That would be 1 minus 1 for that base. And the a value would be 2 minus 1. So the a would be 2 minus 1. Okay, and that's another way to get a to the power of 1 and b to the power of 0. And anything to the power of 0 is 1. So a times 1 is just a. Okay, let's do another example like this. What if we have a coefficient in this one? Okay, let's say we have 4a cubed b squared over 2ab. Okay, again, we can think of these as exponents of 1. And this is division. So what I'm going to do is I'm going to break this up. Okay, these are both numbers. I know how to divide numbers. These both have bases of A's, so they'll be in their own category. And then this next section has bases B's. They'll be in their own category. So my next line is going to be, okay, 4 divided by 2, I know that, that's 2. A cubed divided by a to the power of 1. Well, in the past we saw that that's subtraction, so I need to do 3 minus 1. A to the power of 3 minus 1. And then b squared over b to the power of 1, since it's division, keep the base the same and subtract. So my answer is going to be 2a squared b to the power of 1. And I don't have to write the 1 there. Okay. So we want to kind of look at these as like bases. Let's do one more that's a little more complex than the rest of them. Let's do a squared b cubed over 2a squared b squared. Okay. So when we have a situation like this, there's a lot going on. And because of the power on the top here, we don't want to start dividing first. We always want to simplify the numerator and the denominator, or the top and the bottom, before we start dividing. Okay, so in this case, I want to apply this cubed to each base inside the brackets, and that means multiplying that 3 by each of the exponents. Recall that if you don't see one, it's a 1. So 2 to the power of 1 is the same thing as 2 to the power of 1 times 3 now. Okay, get the right color going here. 2 to the power of 3. And a squared will be a to the power of 6 because of 3 times 2. And then we'll have b cubed. So I've simplified the top. I'm just going to rewrite the bottom because I didn't do anything with that. And now I can separate these into the same bases and start looking at them. Well, 2 cubed over 2, that they have the same base. Okay, this is an exponent of 1. 3 minus 1 is 2. So now I have 2 to the power of 2. I'm going to have a to the power of 4 because 6 minus 2 is 4. And b to the power of 1 because 3 minus 2 is 1. And my last step here is, well, this is something I can do. I can do 2 squared. So I am going to evaluate that and then leave this as is. There's some examples on the next slides to practice. Go check them out.